My first question, since the last couple of presentations have really focused on batteries, batteries are front and center on my mind right now. I'll circle back around to automation in a bit, but battery recycling. What happens as Paul, you guys are already buying batteries, or battery-powered vehicles. On your list of everything, the one thing that wasn't there is, what do I do with all these batteries that I assume contain both precious metals or desirable metals, but also are a reasonable source of pollution. So I would assume that all of you have thought at least to some degree on recycling. So if we can maybe go down the line and
Sure. From a heavy user perspective, if we were to fast forward and say, okay, we have hundreds of vehicles that at some point are going to have to be taken out, whatever the number of cycles to charge, projecting to be 3 to 5 years, depending upon the usage, 1,500 cycles type of thing. Well, we know, okay, what are we going to do when they come back? Is there going to be a program that I think there's going to be a business opportunity for a lot of people out there if they want to start something as far as how to handle all the batteries that will be coming available down the road. But I don't think that's been yet figured out. Much like the infrastructure strategy is not there, much like the facility solutions are not all figured out. I think this is an area that requires a lot of time. There's some teams that are working on stuff in our world, and there's some committees out there with other providers, but I think it's something that still has to be figured out, because I don't think the answers are yet known, Ken. I don't know if anyone else has any.
Yeah, I agree with you. I think we work with some of the early adopters on the hybrid trucks that were out there in the early 2000s, and they're now dealing with, what do I do with these 300 or 400 hybrid battery packs that are out there? And it's not a business opportunity for them yet. They're trying to figure out how to minimize costs to get rid of those batteries, recycle them. I think as new battery costs are dropping, it's going to be more difficult to make that business case. So it's a significant challenge, something that has to be dealt with. I would add the DOE, and it's not my area, but they just came out with a battery recycling prize. So there's a new center kind of created. What are we going to do with all these batteries for both, and light duty is the same, but light duty, heavy duty, the cobalt questions are out there. What makes the most sense to do? How do you disassemble, reuse, recycle these batteries? Yeah, I agree. The answer's not there yet, and it's something I think a lot of the fleets are struggling with already.
So we probably have to develop the problem before we can come up with the solution, is to some extent. In that regard, and I guess a shameless plug, and both Kevin R. and Paul indicated that, and yeah, what are the odds that we end up with two Kevins on a panel of 4 people? But Kevin and Paul both indicated that their companies purchased ACT's commercial vehicle electrification study. So a little shameless plug. We spent about 7 months last year, and 5 of our team members. Jim is the leader. Tim DeNoyer doing the TCO analysis. Fumi Iggy Wright doing the battery work. Brian Armstrong worked on the utility angle, and finally Frank Malley did a lot of work on regulation. We end up with about a 130-page report that so you saw one of the answers, or a couple of the charts anyway from it. So if anybody's interested there, again, I apologize, guys, for
not a shameless plug that you gave. This is a proud plug. It's fabulous. The information you'll get out of that, you won't be able to spend enough time yourself to gather it all. We get a lot of information from suppliers and OEM partners, pieces of that. You were able to bring it all together, as well as add some additional richness to it. So I would highly recommend you look to get it.
Yeah, so yeah, thank you for that, Paul. And so one of the questions that came up, and this is probably a Paul and Jason question, which is, when you're speccing a truck, if you spec just the right amount of battery for the route you're going to haul, you're going to kill your batteries because you're going to drain them too often. And Kevin W., you might have some insight here too. So you need to have over capacity in the battery, and I think Fumi's work indicated that the ideal was about 50% overcapacity, but at the current price of $400 per kilowatt hour, that's a lot of overcapacity in your battery. So as an OEM or as a customer, what's the right number in your book, or how do you think about that?
I think from the OE side, it goes back to maybe what Paul said about co-creation. We have to understand really what's happening with those vehicles, how they're being operated in the field, what routes they're being put on, to really right-size that. When we get into this world, we can't just say it's dual 100-gallon tanks of fuel anymore and you got everything you need. We need to work with customers directly. We need to learn a lot more. We need to get smarter. And not to definitely not to pawn the question off, but there is a certain amount of unknown that goes there that we can only get through working with people directly and understanding how those things should be used.
Okay, thank you.
Well, today there's only a certain amount of space to put as many batteries as you want on, and you still can't get the range. So I think there's a different challenge until we get to a point where batteries can be smaller and you can start to make that decision. If you only need 100-mile range, then you're not going to put 5 batteries that are going to cause you more weight, more payload issues, and then more costs. So I think we're at a point now we can't even go through that conversation of saying this is the application, this is what it's going to need for a range, how many batteries you want to choose. There's not vehicles even being assembled today or produced to be able to make that conversation viable right now.
Right. Good point.
It's a great thing to keep in mind from the OE perspective, though, because we can sell a truck that has X amount of range, but that now limits the end user on where they're going to put that thing, because now it could be over-spec'd. Depending on how you allocate a resource, it could be too large of a battery pack for a secondary operation that they might move the truck into. So it requires another level of thinking than we've had to have in the past.
Yes. Yeah, it blows up your TCO. It blows up your TCO before you even get started if you overspec an incredibly expensive component. Certainly, we saw that in the natural gas applications. I think it's the same in with electrification. Kevin, you guys are developing regenerative brakes. Yes, yeah. It's easy for me to say. I'll give Kevin a chance to say it. If you look at so the most ideal type of application, and anybody else can chime in on any of these. What kind of regen, if I've got a garbage truck or a UPS truck that says stop and start all day, what kind of contribution does regen give back to the truck over the course of the day?
Well, that's going to be highly dependent on the powertrain, the efficiency of the inverters, the efficiency of the batteries. There's a wide range of possibilities, but in many cases you can go through a majority of those duty cycles with very little application of the friction brakes. You'll really be able to harness as much of that energy as possible. So those numbers are probably too early right now to determine what that difference is going to be, but certainly in those applications where you're stopping and decelerating regularly, you're going to have a much bigger return of that regenerative braking.
Okay, so switching the subject to autonomy before I open up to the to the audience, it seems to me that and I think a couple of you at least indicated that the technology for full autonomy is really relatively close, at least on a technological standpoint. One of the things that I've been reading is and from an OEM's perspective especially, who owns the liability, or how much redundancy do you have to have in the vehicle before you're willing to get to a fully autonomous type of application?
Well, I would say from our side, we have a very concerned bunch of lawyers to address that topic and spend a lot of sleepless nights thinking about that. Clearly, it's, again, it's not defined really what that needs to look like, or how that should look in the future. But the onus of safety and the onus of the safety systems we have today is on the OE and on the suppliers. Yep. And as we start to stack those safety systems up and they become automated, and even some of our level 2 systems we have today, the OE does have to do their homework and really own that responsibility, and own the relationship with the supplier, and make sure that all the edge cases are really covered. In the full automated world, I really wouldn't touch that one yet, because we don't know all those edge cases. We don't know what those business models even look like for those trucks. Do we own them? Does Paul own them? Does Kevin own them? Who really owns those trucks, and who has that responsibility in the end? So that one is a little bit further, but right now where we do have these semi-automated systems like our level 2 trucks out there now, we do have the onus of making sure that those things perform, and working with our suppliers and making sure that those things are safe 24/7.
And certainly you want them to perform, but as I mentioned, the driver is still the key responsible element in the system. And so that has been the continuous messaging for 15 years. As we start looking at automated now, that changes. And that's where some of the difficulty and the unknowns are going to start to be rationalized.
It was a very good point, because we just heard earlier about driver training and driver awareness of some of the safety systems this morning. We build these fancy things that can do amazing things to reduce accidents, but if drivers override them because they beep too much, or they don't like the way that the throttle responds, or the brakes hit, and they override them, then the onus of the responsibility picture really starts to change. And that's also where the connectivity element starts to come into play, because now the customers, the end users, the OEs, the tier 1 suppliers of those systems want to know, especially even in the case of an unfortunate litigation, what is it that happened with those trucks? And having those trucks connected, telling them what's happening with those highly specialized safety systems will become that much more important going forward, to make sure that we're capturing how the driver's intervening with those and behaving with those systems.
Okay.
When I get that question from either a customer, a supplier, one of our associates, I turn that more personal. And I say, let's not talk about the truck. Let's talk about the car you drive. Apologize. Let's talk about the car that you drive. And I'll even say my own family. So I have 3 boys. And if they're in an autonomous car on their phone or watching a movie or whatever, and they're just waiting to get to where they're going to get to, and somebody hits them, how would I feel? And who hit them? Did somebody hit them that also had an autonomous car? Or did somebody hit them that didn't have an autonomous car, and they were waiting for the car to take over and do what it was supposed to do? And then you put in, as I think through that, I put myself into other circumstances and situations. So who's going to program that car to do what it's supposed to do? And now it moves away from the car that's, running crazy without any autonomy on it, and it's got to go off the road into the sidewalk area. And what is it going to do? Is it going to run people over? Is it going to hit another car? Is it going to crash itself? So I don't even worry about the commercial side of it. I try and personalize it. And if you start thinking about it that way, ask yourself, what would you want that programming to be? And I think that is the big hurdle that we're going to have to deal with before we get to trucks and regulation and insurance companies and others allowing that to actually come to be. I also think that's many years into the future. Then you got to ratchet it back, okay, level 4, level 3, and then you start saying, okay, let's really talk about what can be done there.
So the ethics of autonomy is, do you kill the baby or do you hit the school bus? That's
That's another way to put it.
Yeah. So I've got 2 more questions, and then I'll turn it over to the audience. First, Paul, with looking at kind of the building blocks of autonomy, so lane keeping, adaptive cruise, automatic braking. When your lease customers are coming in and speccing trucks, can you quantify kind of percentages? And Jason, you might kind of know on a DTNA or a Freightliner basis, but are these technologies being gobbled up, or are people saying, oh, those are kind of expensive?
Well, they are saying that. If Daimler wants to lower their price, we'd appreciate it.
Working on it.
But what's interesting is the adoption that we've seen in other technologies, this one is collision mitigation systems are outpacing the ones that we've measured in the past. So which ones am I referring to? Referring to automated manners. I heard of in the previous session, we were mentioning it's up to 80%, they believe. So we saw it go from 10% when it was first introduced, jumping to the mid-30s, jumping to 60, and then it was at the high 80s to 90s, and that's where we are today. If you go to collision mitigation, we're seeing the same thing. It started in the 10% range, it jumped to the mid-30s, it's jumped even faster to the 70 percentile, so we've seen that adoption happen a lot faster. And I think once you explain and you put in front of a customer or prospect the benefits of it, and it was talked about this morning, they were given some realistic examples and some of the litigation challenges and so on. It's an easy conversation, or it's an easier conversation if it wasn't easy before. And we, in our organization, now we went 100% with our tractors. Our rental fleet is now 100% collision mitigation. And we're at that 70% of every new customer that we come on board that's going with that technology.
Thank you. Kevin W., just circling back around to electrification. Have you guys at NREL tried to quantify what the infrastructure needs to look like? It seems like certainly a chicken and the egg type of situation. I get it for small local fleet. So I come home to the same garage every day, and I can charge my electric truck and send it back out on the road. One of the big hurdles, it seems to me, to move electrification into heavy duty and outside of that distribution type of fleet is getting to this chicken and the egg problem. I don't want to invest in the infrastructure because there's no electric trucks. I don't want to buy an electric truck because there's no infrastructure.
Yeah, we've started looking at that. I think the point's been made. It depends on the application, right? I mean, we have information on what it's going to take to do a centrally charged fleet versus a on-the-road fleet. I was going to add in, when you guys were talking about battery life, it's a complex equation when you start talking about what do you want to optimize if you're looking at battery life, depth of discharge and cycles per day and C rates and temperature. All that is part of the battery life equation. So same thing when you're thinking about infrastructure, like, okay, do I want to do 50 kilowatt, 350 kilowatt charging? What do I need versus what's the range of the vehicles? How much battery do I need to have on board the vehicle versus how fast do I want to charge them? How many times a day do I want to charge them? So every application is going to be driven by maybe a different equation, but certainly we're starting to pick apart those pieces and understand, okay, what are some of the limits as far as where do you start running into problems on the distribution feeder side? What about some of the costs involved with putting in multiple high power charging racks for 50 to 100 vehicles at one site? Or is it smarter to put bigger vehicles on, or have bigger batteries on the vehicles, or have extra vehicles out there? So we don't have one answer yet, but I think we're starting to dive into all the different pieces that fleets need to think about. How do you spec out the truck? How do you spec out the charging? And then what are all the different costs? And again, I said there's over 30,000 different utility rates out there. You start thinking about, well, where are you doing this? Are you going to do it in San Diego, which has the highest demand charges and utility rates in the country? Or are you going to be doing it in the Northwest, where they have hydropower and electricity is cheap? So, it's a different answer for different vocations, different applications. But I think we're trying to dive in on a lot of those pieces right now, and hopefully, we're from the government. We're here to help. Hopefully, we're trying to get some information out there to you guys to use for your specific applications. But we're trying. Attending shows like these is helpful for me to kind of see what you guys are worrying about, what you need help with, what data and what tools you need.
Okay, all right, thank you. So are there any questions in the audience? Bill Morrissey got one. Oh, we got a bunch of questions. So Bill Morrissey was quick. We got one up here in the very front.
I got one first.
Oh, okay, Fumi's got one. Okay.
All right, so I used to think platooning was going to be a big benefit in autonomous vehicles. And then recently I heard something from Daimler saying, oh, we're not looking at that anymore so much. So I guess I have a question for Kevin W. and probably Jason. Do we really have some benefit with fuel economy on the platooning? And why is the story so different? Or at least from my perspective, it looks different.
I'll let you go first.
Okay. Yeah, so what you're referring to is our announcement back in January at CES that we were shelving our platooning endeavors to focus more on level 4 autonomy. The technology that goes into platooning is really complicated, and a lot of it has overlap with the technologies that you'd implement for level 4 automated vehicles. We see it also from a practical standpoint in that trying to get vehicles to platoon of the right technology, of the right state of technology, having the same kind of air brakes, having the same type of an ability to intercommunicate between the two trucks and operate them safely isn't necessarily there yet, and it's a long way to get that to a state we believe we'd want it to be in to productionize it. And are then thinking in that light, our efforts are better spent to push towards a purely level 4 system. Now, clearly the gains can be there under certain conditions, right? The fuel gains, it's simple physics. It's aerodynamics flowing over vehicles that are right behind each other. But when it gets really tricky is when you're talking about a truck of a different weight behind or in front of a vehicle of a lower weight, maybe slightly different brake wear, maybe slightly different communication latency capabilities on each vehicle. And then you start to see the potential breaks in why that may not work so well. Put them on 2 straight roads, let them go, the benefit's there. Put them on a hilly road, put them with different weights, it starts to get hard to control. And there we think we need to spend our efforts in other areas.
Yeah. And I would add from a DOE and NREL specific perspective, we've done some testing on some trucks on a track. Yeah, we've seen upwards of 10% improvement in fuel economy for a pair of trucks. I think there's some data out there on even 3 trucks platooned. But as Jason says, yeah, the ideal best case, you start chipping away at that when you start adding in loads and engine type. One of the interesting things we saw come out of one of our platooning studies is the following truck, depending on what distance, what engine, and what load it had, there's some cooling issues there. You don't have the ram air coming into the second truck. So now you got to maybe adjust the trailing distance, which might affect, it starts to chip away at that efficiency gain that you're going to get. Another thing we've done with some of the national freight movement data that we've had out there and some of the data we have from the trucking companies is trying to understand, well, where are trucks going now? How likely is it that similar trucks can link up? Is that really, what percentage of total travel do we really think we can get in? And it starts to break away from that and take away from some of the ideal efficiency gains that you might see.
Agreed. Bill?
I would add the connectivity part of it might be able to bump that up a little bit. Like if you can talk to the trucks more and you kind of know routing and understand where the vehicles are going, it might give you more opportunity to link those trucks up and the right kind of trucks platoon together. So that's maybe where the connectivity piece of it starts to
And we looked at that as well, but then that turns into an operational decision for our end customers. I have this set of trucks that can platoon. Before they used to go here, now I need to make sure they go there, but let me replace these. So it's an operational new concern if we start to go down that path, and we're not 100% sure that that's the way we want to go.
Okay. Bill, Morrissey, you had a question?
Yes. It seems that each manufacturer is able to put together, design, and actually test electric trucks today. The infrastructure that's going to support this, and I forget who did the presentation, but one was one of the, oh, that's better, okay. One of the recharging illustrations with solar power. Now, I know that's simple, clean, and neat on the presentation, but in reality, East Coast, Midwest, there's no sun. So, you know, the strain on that situation, that doesn't help the infrastructure. What is being done on the infrastructure? Because I do know that each one of the OEs is testing trucks right now, but they have to be recharged.
I could maybe take a shot. I'm a vehicle guy, but we have a pretty big grid team at NREL looking at renewables on the grid and what's the best way to implement that. Yeah, there's a lot of testing going on out there. One of the big themes right now is grid storage. You know, renewables are intermittent. How can you store some of that? Can you store it as electrochemically with batteries? You know, hydrogen, we're talking about large-scale hydrogen production, maybe as a storage mechanism. So what makes the most sense, whether it's wind or solar? Again, there's a lot of different utilities out there, but like NREL, for example, renewable energy is kind of our core mission. We understand the diversity at what works in what part of the country and what doesn't. So looking at the resources, so again, it gets back to that. You know, it's really site specific, and it's utility specific, and then it's technology specific. What's your duty cycle? What are your loads? What are your generation? How do you bring all that together? And again, I think we're trying to develop some of the tools and the data that if you're a fleet and trying to think about, you know, should I put renewables or storage? What about electrifying my vehicles? You know, being able to look at the value of each one of those site specific. But yeah, there's I'd say the DOE and the national labs, they have pretty significant grid distribution test research activities going on right now to really try to understand what's the right way to integrate renewables. And from a vehicle's perspective, how can we start electrifying vehicles and make sure that we're using those renewables. I don't know if you guys have all seen it, you know, the duck curve in California with solar production, when it happens, and then when the loads are coming on and off, and it's a challenging control problem as maybe you put too much renewables on the grid. Now, what are you going to do with it? Maybe there's a way to shift the load of vehicles to maximize that production. So a lot of different challenges depending on where you are, but yeah, a lot of research, a lot of modeling, simulation going on right now, as well as a lot of hardware testing.
And from the OE side, you know, you mentioned a lot of OEs can put electric trucks out there. That's for sure. You know, we can do that. But we also recognize that does not turn into a productionizable solution unless that infrastructure piece is developed in tandem. And that's why, as we're working forward with our work on it, we have a team dedicated just to the infrastructure problem. So while we're talking about people designing, we have an infrastructure party as well. And they develop in tandem, working with the government, working with the customers, because we realize that in the end, you don't have a solution if you don't have both those pieces tied in together.
So I think we're already pushing over time, but I've got one question here in the front row, and did I have one over here? Okay, so we'll get the one in the front row, and then we've got two more questions, and I thank you for indulging us for an extra couple minutes of questions, but please go ahead.
Hi, thanks again for making your time available. My name is Danny Howe from Jabil, and having an OEM and a Tier 1 supplier, this is in regards to autonomous vehicles. How do you guys choose who are the technology providers in terms of what ends up being on the vehicle? For example, looking at Kevin's presentation, there's a lot of these AI startups providing software. Who ends up floating to the top and who makes that decision?
You want me to go first? Go right ahead. You know, it's an interesting thing because it's not a typical supplier vetting process anymore, right? It used to be, you know, could you cast or mold a part, and were you the cheapest? Did you have the best quality, et cetera? It's a lot more complicated than that now. The piece for us is really who can best work with us on our joint vision for the future. And there's a lot of companies out there now that have their own vision of how that thing should work. Should it be LiDAR based? Should it be radar and camera based? Should it be X, Y, and Z? we have a lot of smart people that have their own opinions, and we have to determine who's our best partner to work with on that. You know, we work with Bendix on a lot of solutions. We work with other suppliers. We do a lot of internal development there. It's a highly contentious process, right? You know, we have some very, very smart competitors, particularly out on the West Coast, that fight us in that region. The criteria for selecting them is really diverse. I can't go into too much detail on it, obviously, as far as the process goes, but it's all about really joining vision. What is it they want to do? What is it we want to do? And what can we do together? I know that's kind of a really a white statement, unfortunately, but I can't go too far into the actual nuts and bolts of how we would select. But just be sure that it's quite different than a traditional mechanical part or something that we had sourced in the past.
I think to just build on what Jason had mentioned, there's also the shift from what's the technology to the software. And that process for making those decisions on partners are going to not only be based on what's the part and the component that goes on the vehicle, but how is that put together with software companies or with software. And so, you know, as there are statements that have been made out in the public about the startups really being software companies and how does that transition to real vehicles. I think you're going to see that list of startups start to work its way down to the suppliers in the marketplace that have the wherewithal to go through the validation and go through the support and the partnerships with the OEs and the fleets in order to really bring that technology into the marketplace.
So last question, Ken? No, you've got the microphone. You've got the last question of the of this session.
This turned out to be a discussion of electricity. What's going to have to happen with the government in terms of regulations, and where does renewable, say natural gas, fit in this? That is another source of fuel that will meet emissions. So where's the government on regulation? What has to happen? And what about renewable natural gas?
Yeah, I guess. So I'm not involved in the regulatory decision making at all. It's more along the EPA or DOT. I can say yes, the DOE, we're kind of technology agnostic. Yes, we have a renewable natural gas program going on right now. Looking at that, we think it's got definitely some viable options, different applications, renewable, you know, different ways of making hydrogen also. We've got a lot of different combustion biofuels program out there too. So it's not, not all electrification. Certainly regulations, depending on which administration comes in and what their focus is, and maybe it's California or the Northeast, maybe it's a federal approach, but yeah, we're trying to understand what all the different pathways might be, and there are a lot of different options, but yes, we are working on renewable natural gas, different hydrogen, and also a lot of biomass, biofuel research going on right now too. So whichever way the regulatory environment steers the technology, I think, you know, there's a lot of different technologies that these guys are trying to figure out what works best for their customer, but we're not abandoning any one technology at this point.
All right, so with that, I think we should give a round of applause to the panel for an excellent job. Thank you all for coming in, and